Alright, so in this video we're going to be talking about rearranging formulas. We've already learned how to solve simple 1 and 2 step equations like solving for x. It's not really too much different than that. The only thing that may confuse you is there's going to be a few more variables thrown in instead of numbers. So the main key things here are that we're going to isolate the variable that they tell you to. So there might be 3 or 4 variables in the problem, but you have to know which one that they want you to isolate. Otherwise you're going to start solving it the wrong way. We may have answers that look crazy. Does not mean that they are wrong. So unless you are just confident that you didn't know what you were doing, crazy looking answers could be actually right. And we're going to use the same strategies we did when we were solving those 2-step equations for x, just with more variables. So it's the same idea, so don't think it's anything harder. Alright, so let's just start off with a review of what I was talking about a minute ago, solving for x. We've already talked about this, and this one has a y in there too, so this is why we consider this step thing that we're doing here a rearranging problem, not just a solve for x. So if we wanted to get y by itself here, because this is the standard form equation of a line, and what we were doing previously was we were quote-unquote rearranging this equation and solving to get it into slope-intercept form, which is the y equals mx plus b that we've been messing with for a while now. So we've already been kind of rearranging equations, just didn't call it that. So getting down to this problem, if I want to solve for y, in order to get it to look like this, I need to move some stuff around. So again, kind of going back to the whole idea of isolating a variable, I'm going to box what I want to get by itself and move everything else away. So I'm going to leave the y where it is momentarily, and we're going to always move, remember for these type, the x term away first. So if it's in standard form and I want to get it into slope-intercept, I'm always going to have to move that x term first. So we're going to subtract 2x to undo addition. And we're going to be left with 4y equals negative 2x plus 12. Well, we still need to isolate y, and he's not by himself yet. So I need to undo multiplication by 4 by dividing everything on this side by 4. So y equals, and then we're going to start reducing, negative 1/2 x plus 3. So now we've got y by itself, so this would be your final answer, and that's also in slope-intercept form like we wanted to begin with. So we've already been rearranging formulas, we just didn't call it that. So if we say solve for x or solve for y, that's still rearranging no matter how many steps you have, 1, 2, 3, or however many. So let's look at something that has more variables. So we have c equals 2 pi r, and hopefully this is one of the formulas that's jumping out at you that you've seen before. This is for the circumference of a circle. And while pi looks like a variable, and we can call it a variable, it actually has a value that goes with it. So the variable we want to solve here is for r. And so if I want to get r by itself, we know that we need to isolate him, and we need to undo some stuff that's being done to him. So if we look, 2 is being multiplied by pi and then by r, and so it's all multiplication that we need to undo here. There's no addition, subtraction, or division for that matter. So if I want to undo what's being done to r to get it by itself, I need to divide, since we're multiplying, and I can either take this in 2 steps or I can take it in 1. So since 2 and pi are being multiplied by each other, I can actually take them together as long as I keep them being multiplied together. So I can divide both sides by 2 pi. So the 2's cancel, the pi's cancel. Well, now I've got r, which is what I wanted, and r is now equal to c over 2 pi. Well, at this point, again, as ugly as this may seem to some of you, this is the final answer, and it's correct. If there's nothing that can simplify, there's no other numbers we can bring in to simplify, that's all you can do. And so you would just leave it like this and call it done. So let's try another one. So this is area of a circle. So hopefully it's a familiar one. And again, pi is sort of considered a variable here, but it's actually got a value behind him, 3.14, so on, so on. So we're actually going to try to get r by itself here. So we need to isolate the r. Well, to begin with, before I get the r by itself, we know that pi is being multiplied. So I can divide both sides by pi to get the pi gone on this side. And so now I've got a over pi, a divided by pi, equals r squared. Well, r's not by itself yet. We still have r squared, and I don't want r squared. I want just plain r. So we talked about this in a few earlier videos about the inverse operations, and we've been doing inverse operations to get these variables by themselves, but now we're kind of at a roadblock that if you don't know this inverse, you're going to be stuck. So you got to remember that the inverse operation of squaring something, since we have r squared, is square rooting. So I want to square root both sides. So the square root and the square kind of cancel out over here because they're inverses. So we're left with r, which is what we wanted. And r is going to be the square root of a over pi. And we could talk about rationalizing this. Usually you don't want a radical in the bottom, but we're just going to leave him for now like this, and we'll talk about rationalizing stuff later. So right now, again, as ugly as it may look, that's your final answer that you're going to need. Alright, this one's a common one too. They like to throw at you, and hopefully you're seeing this is your perimeter of a rectangle or a square formula. And so let's just say we want to, let's do L. We'll get L by itself. So if I want to get L by itself, I need to start moving some stuff. So remember your opposite PEMDAS. We kind of need to go backwards. So we need to take care of subtraction and addition before we do any multiplication division. So I need to move this 2W to get him to the other side first. So it's kind of like standard form of a line that we were moving the x term first. I want to move this 2W first. So on this side I'll have P minus 2W equals 2L. Well, I still don't have L by itself, so I need to get rid of this 2 in front of it. So I need to divide everything by 2. So we can leave it like this. We can say L equals P minus 2W over 2. Or I can break it down with this common denominator. We can say P over 2 minus 2W over 2. And we can take it even further if we wanted. This is P over 2 minus, and then the 2's cancel, so just minus W. So sometimes they'll just leave it like this. Sometimes they'll take it a little bit further. You just need to know how to do all of it, just in case. Alright, this one's one that the state likes to throw out a lot, just to see if you're kind of making sense with context of what we're doing. So, I don't know how many of you are familiar with this formula, but this is the way you convert from Celsius to Fahrenheit and vice versa. So that has to do with temperature, which we all live in, and in Georgia we know how hot it gets. So, you know, in other countries they don't use Fahrenheit, so if we were to travel somewhere we would need to know how to get it into Celsius to kind of be able to do some comparisons on what we're seeing. So this is a real world application of how we need to rearrange formulas, because this one is set up to where Celsius equals 5/9 times F, which is Fahrenheit, minus 32. But what if we were in a different country and we were trying to figure out what the Fahrenheit was, and their thermometers was giving us Celsius? So what if they, for instance, told me that it was 22 degrees Celsius? Well, how would you know what the Fahrenheit was? And we could go plug in here and plug it in for C here, but we would have to work backwards to isolate F. So if we can go ahead and isolate F and come up with a different formula by rearranging, then all we have to do is plug this 22 degrees Celsius into that new formula, and we would have it right off the bat. So let's see if we can rearrange for F here. I want to get an equation for Fahrenheit instead of Celsius. So let's kind of look and see what's happening. So a lot of y'all are seeing parentheses, and I'm pretty sure some of y'all are tempted to go and distribute here, which may not be a bad idea, but I want you to notice something. If you do 5/9 times 32, it's not going to be a pretty fraction. It's not going to reduce down pretty. So what I'm going to suggest we do is take care of this fraction out front first, and then we can do some other stuff. So if this 5/9 is being multiplied by this whole parentheses, F minus 32, I need to undo multiplication by division. Well, I need to divide both sides by 5/9. Well, think back to elementary school. If they did 1/2 divided by, let's say, 2/9, all right, some fraction, there was a trick that your teachers probably taught you, to keep, change, flip. They said it somehow, or multiply by the reciprocal is the technical term. So if I really wanted to do this, I could do 1/2 times 9/2 and flip it, the reciprocal. So if I want to divide our equation on both sides by 5/9, I can really multiply both sides by 5/9 and be happy. It's the same thing. And notice what happens. Oops, sorry, did that backwards. You wanted to multiply by the reciprocal. I didn't flip it yet. So we want to multiply both sides by 9/5. That's my fault. And watch what happens. The 9's cancel, the 5's cross cancel, so that goes away. So on this side, we've got 9/5 times C equals F minus 32. So now I only got one step away to get f by itself. I need to add 32 to both sides. So f equals 9/5 c plus 32. So now I have an equation in Fahrenheit, in terms of Celsius, that if I wanted to, for instance, convert this 22 degrees Celsius, I could just plug him in here now and figure out what he is. So it's a real-world application why you would need to know how to convert between one formula and another. So here's some practice questions, and as per usual, go ahead and just make sure that you are pausing the video to do these problems. Don't go look at the answers until you've tried them on your own. If you don't get how to do it, go back through the video, rewind it a little bit, review the problems, and make sure that you know what you're doing before you go and look at the answers. So pause your video right now, and let's see what you can do. Alright, here's your answers. And I'm just going to kind of not talk too much through it, through the steps. You can read those, but just on this one, make sure that you are isolating the variable they want, since there are more than one in here, and make sure that you're multiplying by the reciprocal. That's the main thing here. On this one, key here is just think of that b sub 1 plus b sub 2 as one whole entity to begin with, and kind of it travels together. So when you start dividing by it at the very end, that's why I divided by the whole thing in parentheses, because it's one entity itself. On this one, these are familiar. We've been doing these isolating the y, but now it says x, so it's the only difference. You got to move y first. And then the only thing I want to mention down here at the bottom is that you can leave it in this form to begin with. That's a valid answer, but I just need you to know that these can also be simplified a little bit more usually, and so I don't know which way you'll see the answer, but just know that the answer I put over here to the right is actually just coming straight from the one you got on the left, so they're both valid. Alright, and then on this one, big key here, just so you know where I got stuff, I pulled the negative. Usually this negative can't stay down bottom, so they'll either put it outside here, just in the middle, or they'll actually pull it up top. But if you're pulling it up top, you got to put this whole thing in parentheses, because we're not just applying the negative to the 2x, we're applying it to the whole thing up top. So that's how I ended up with switch signs over here, because when you distribute this negative, both of those things become negative now. So just to make sure you know where I was getting the negative 2x minus 7 in this second step, just had to pull the negative up and distribute, because usually, like I said, they're not going to leave the negative on the bottom. Alright, so until next time, keep practicing.